Okay, so today we're going over like 5.2, the definite integral. First of all, we should know the definition of the definite integral. The definition of definite integral said the integral from a to b for the function f of x, that of x, is the same as the limit sum of the function f of x stars delta x. Okay, by the way, what is delta x? As you see before, like in 5.1, what's delta x?
Oh,
What is delta x?
isn't it b minus a over n?
Exactly. So delta x equal the limit of the sum for f of x I stars delta x I equal 1 to n from n equal goes to infinity. Okay. Again, delta x, as we learned from previous section, is the same as the end point minus the beginning point of the interval over n, delta x. And what is x? What is x I stars? What is that? As you learned before, it's called what? What is xi star from 5.1? It's called the sample point. Sample point. Xi star is sample point. Means a point inside the subinterval. You can pick this point from the subinterval of the long interval from A to B. Okay. So I can say here sample point from each subinterval. Okay, by the way, we said last time the integral is the same as the limit of the sum. And we say these things is, we talk about this one from 5.1 all the time. We say this is like the area under the curve. But we have to say now in this section, because the integral takes different sign, sometimes positive, sometimes negative. I cannot say the area all the time. I cannot say the area is negative. I can say this is the net area. What does that mean? If the function here is positive all the time, this is mean the area under the curve. If function here is positive, but means like what is non-positive? Taking like positive values all the time for all the interval. But if the function here is sometimes taking positive values and negative values, so I can see here the net area. What's the meaning of the net area? Means the area above the x-axis, the total area of the region above the x-axis minus the total area of the region below the x-axis. Okay, so it's called the net area. Now, uh, let me just define something. So first of all, I'm gonna like say this is a symbols of the integral. It's called integral sign. Okay, this is called here integral sign. This is the integral sign. I know this is the first time you see something that like this symbols. So this is called the integral sign. Second things, f of x here, I'm gonna define it as something called integrand. It's called integrand. Just this is some notation, okay? And again, the a and b, this value a and b, here's the a and b, this things. This is called the limit of the integral. A comma b are the limit. Put here, a comma b are the limit of integral. This is just a notation you should know, because this is the first time you see the integral. So the a and b are the limits of the integral. This sign is called the integral sign, and f of x is called the integrand. Okay. I'm going to give you another note, because this actually, this is a number. This is a number. What does that mean, the number? Like a value, number. So the integral from a to b for f of x del of x is a number. This is give me a number, and this is give me a number. So this is mean this integral does not depend on the value x. Does not depend on the value x. I can change it to t, to the r, to everywhere. Okay. So here I'm gonna give a note. They said the integral from a to b for the function f of x del of x is a number. Means the value is a number. So it does not depend on x. So this is mean I can like evaluate, I can say like the integral for the f of x del of x from a to b, because it's definite integral. Definite integral means it has a limit. It has a limit. It has a limit of the integral. Again, for the student who coming after like 10 o'clock, I put the link of the attendance in the chat box. Please fill the attendance. Okay, so here go back to the class. The integral for f of x del of x is the same as the integral of the function f of t del of t from a to b is the same as the integral for f of r del of r from a to b. Doesn't matter what's the letter inside the integral, okay? T, R, X. Why? Because the function is depending, is a definite integral and the value is number. Does not depend on the variable. I'm gonna give you a quick example for this. Before I give you the example, I'm gonna like also remind you, this is for the another note, is I said like the sum for the function f of xi stars delta x from I equal 1 to n is called the Riemann sum, okay? It's called the Riemann sum. So again, so the integral from a to b for the function f of x del of x can be as area, like I said, under the curve y equal f of x. But here, if the function is positive, if from a to b, since f of x is greater than 0 for all values, means it's positive. Okay, I'm gonna explain this by giving you a small like graphs. I'm gonna like add small graphs. Here is the graph. Look to this graph. The function here is positive, means all values above the x-axis. Okay, all values is above the x-axis. So they said because the function is positive, the Riemann sum here is the area of the rectangles. As we learned last time, we divide the area into subintervals, into rectangles, and we find the area for each rectangles. And we find the approximate area under the curve. So the same things for integral. If the function is positive, the integral is the same as the area under the curve. Make sense? What about the function if it has positive values and negative values? What's happened to the area? What's happened to the integral? Sorry, what's happened to the integral? Okay. Here's the another graph. This is the second one. Okay, now for the second one, look, the function takes positive values, negative values, and positive values. So what does that mean? This is mean the integral, you see the integral is the same as the net area. Net area means the area above the x-axis, the total area of the region above the x-axis minus the total area of the region below the x-axis. So here I can say this is the same as A1 minus A2. What does that mean? I can say this is the same as the total area of the region above x-axis minus total area of the region below the x-axis. The net area. So when the function has to take different values, because positive and negative, you have to find the net area. Okay, I'll give you an example. Evaluate the Riemann sum for the function f of x equal x to the power 3 minus 6x, such that x between two values 0 and 3, with n equals 6 subinterval and take the sample point, the sample endpoint, to be the right endpoint. Okay, I'm gonna ask you questions. What is the how many subinterval I need for this example?
6.
6 subintervals. Nice. So, and my second question, what is the sample point? What is the sample point here? Like last time we said the sample points could be right endpoint for the subinterval. It could be like the left endpoint of the subinterval. It could be the midpoint of the subinterval. It could be any point inside the subinterval. So what is the sample point in this example?
Right.
The right. Exactly. Look, to the right endpoints. It could be the here in this question, in this example, it would be like the right endpoint. So first of all, to find something like that, you know, they ask about what? R of 6. R of 6. Why I said why you said R here? Because right endpoint, so I used R. Left endpoint, I use what? L. So right endpoint would be like R6 equal the sum of the function f of xi star delta x, starting from I equal 1 to 6. Okay, now we're going to find, like, as we learn, like I give example like this last time, we're gonna like find the subintervals, we're gonna find the f of the right endpoint of the subintervals, we're gonna find the delta x, all the stuff to find R of 6. So what is the delta x here? What is delta x? 1/2. How you find it?
3 minus 0 over 6.
Exactly, 3 minus 0 over 6. 3 minus 0 over 6 is the same as 3 over 6 is 1/2. So delta x is the width, So the width is the same for all subinterval. It's 1/2. So I'm gonna graph a line. Starting point is 0, ending point is 3, and I need 6 subinterval. So I'm gonna divide this interval up to 6 subintervals. So 6 subintervals means I have so here I have 6 subintervals. Here's the first. Okay, 5. Here's 1, 2, 3, 4, 5, 6. Correct. So this is the first one. This is the second subinterval. Here's the third one, fourth, fifth, and sixth. Now, like I said, delta x is the same for all subintervals. It's the width for all subintervals. So it means this point is equal to x1, x2, x3, x4, x5. So the point x1 is supposed to be like the first point is 0, is a, plus delta x. This point is a plus 2 delta x. This point, it has to be 3, a is the first point, is 0, plus 3 delta x, and so on for all of them. So for the first one, x1 is supposed to be 0 plus delta x is 1/2, correct? Would be like 1/2. The first point is 1/2. I'm gonna like write it here, 1/2. Okay, the second point is supposed to be like a plus 2 delta x. It's supposed to be like 0 plus 2 times 1/2. It's supposed to be what? What's the value? The value is 1. 0, 1/2, 1. Now you have to keep adding the same delta x for all the points. So the x3 is the same as the 1 plus delta x. 1
So
plus
it's
delta
3/2.
Exactly, 3/2. And the same things for the third point, you have to be like 3/2 plus the delta x. What is delta x? Is 1/2.
It's
1/2
2.
plus 3 is 2, correct. And here 5/2. And here is like 6/2 is the same as 3. Okay. Now they ask for the right endpoints. The right endpoint is supposed to be what? The value of this point for the first interval. This is the first interval. Second interval is supposed to be here. This is the right endpoint. This is the third interval. Here's the right endpoint. Here's the fourth interval from here to here. This is the endpoint. I'm gonna like write it so quickly. So here the sub-intervals are 0, 1/2, 1/2, 1, 1, 3/2, 3/2, 2, 2, 5/2, and the last one is 5/2, 3. So again, the right endpoint is this point, this point, this point, this point, this point, and this point. Okay, I'm gonna like fill using this formula to substitute all these things, the delta x and the f of each of right endpoints. Okay, so R of 6 equal sum of f of xi delta star delta x from I equal 1 to the 6. Because the sum depending in I, so this means delta x is a constant. I can take it outside the sum. Okay? Again, because the sum depending on I, because here we have I for the function, delta x, I can take it outside the sum. So it would be like delta x sum of the f of xi star I equal 1 to the 6. And here is 6. Okay, so this is the same as delta x is the same as 1/2 f of xi f of x1 plus f of x2 star, plus f of x3 star plus f of x4 star plus f of x5 star plus f of x6 star. Now I'm gonna plug the values so quick. So it'll be like f of 1/2 plus f of 1 plus f of 3/2 plus f of 2 plus f of 5/2 plus f of 3. Now, what is the function? What is f of x? To plug these values. What's my function? What is my function? Here's my function. Exactly, x to the power 3 minus 6x, correct. Genuine. X to the power 3 minus 6x. So we're gonna plug these values inside the function. Okay, I'm gonna do it very quick. This is like, because I have the answer. You can do it like if you wanna like make sure like you can like repeat, check when you plug the 1/2. So we're gonna plug the 1/2, you're gonna get minus 2,875 plus f of 1 is minus 5. F of 3 over 2 is minus 5, comma 62. 5.625, and f of 3 is minus 4, and f of 5 over 2 is same as 0.625, and f of 3 is 9. So the total answer for this one is the same as minus 3, dot 9375.
Can we just leave it like the top answer
The top answer?
without getting
If,
the exact number?
yeah,
Yeah.
if because the calculator is not allowed, so you can like plug the value 1/2 inside the, or I can keep it like this. It doesn't matter. It's fine. Here, the answer is minus. The area here is minus. Not, I can't say the area. I can say like the answer is minus. What does that mean? The total, what does that mean? The total area above the x-axis minus the total area below the x-axis is negative. Means the total area below the x-axis is greater than the total area above the x-axis. Make sense? So I'm gonna like show you exactly what does that mean. Like here is the graph of the function. Here's the graph of what we did right now. So this is the one. This is the graph of the x to the power 3 minus 6x. So look, the total of the area below the x-axis, here's the x-axis, is greater than the total area above the x-axis. That's why the answer is negative. Because I said before, the area, the net area is the area above the x-axis minus the area below the x-axis. So this is the Riemann sum is negative 3.96, 9375.
Professor,
Make sense?
if it asks for the left endpoint instead of the right, what difference would it make?
If they ask the right endpoints, we use the right. This is the right endpoint.
No, if it asks for the left.
Left,
instead of
you're
the
gonna
right.
use, for the left, you're gonna use this point. This point. This is the point for the left. Make sense?
Yeah.
For finding the, can I say?
Again? Yeah, go ahead.
For finding the midpoint, right? We subtract the
midpoint
B and
is
A.
the midpoint is the point here between 0 and 1/2. It means you have to add 1/2 plus 0 over 2. 1/2 plus 1 over 2. 1
So
plus
it's
3.
A. So it's A plus B over 2.
Exactly, A plus B over 2.
Okay.
A plus B over 2 for the midpoint. Correct. Make sense? Any question? I'm gonna give you like the general theorem for these things. For the, so here theorem. So if f is integrable. By the way, here I should say like, what is the mean of integrable? What's the mean of integrable? Integrable means Here I'm gonna like add some small notes for these things here. So if the limit does exist, this limit, you know, as we learned before, like we said, the limit sometimes does not exist, right? As we learned like in previous sections, sometimes the limit does not exist. If this limit exists, I said f is integrable on this interval. Makes sense? Sometimes the limit does not exist. If it does not exist, means it's not integrable. But if the limit here exists, means the function f is integrable. Now, again, if the limit sometimes, again, this is like one way. I mean, like if the limit exists, then the function is integrable. But if the limit does not exist, sometimes integrable, sometimes does not integrable. I'm not sure. But here, like they said for Riemann sum, if the limit exists, this is one way. So this is mean like the function is integrable. So we should to know these things. I'm gonna like bold it. Okay. Now go back to the theorem. If the theorem said if the function f is integrable, means it has a value on the interval from a to b. Okay, then the integral for the function f of x, del of x from a to b, is the same as the limit for the sum for the function f of xi delta x. Here I equal 1 to the n and goes to infinity. Okay, so again, what is delta x? Is the same as b minus a over n. And xi, what is xi? Is the same as a, the beginning point, plus delta I delta x. So this is the mean of f is integrable. I'm gonna give you like example, a quick example for this. Express the limit of the sum I starting from 1 to the n and goes to infinity for the function xi to the power 3 plus xi sine of xi delta x here as an integral of the interval from 0 to pi. I get the question, is that the area for the complete function? This is the, I can say the approximate area. Is not exactly the area, approximate area from Freddy. He asked question, is that the area for the complete function? Is approximate area. But the approximate area here is negative. Why? Because the approximate area above the x-axis is smaller than the approximate area of the total area below the x-axis. Now express this as integral. So how can I express this as integral? How can I express these things as integral? If you look into the theorem above, the theorem said if f is integrable in the interval from a to b, then the integral for f of x del of x is the same as the limit sum. Limit sum. Okay, I have actually the limit sum. I have the limit sum, and this is my f of xi actually. This is my f xi. So I'm gonna like put these things as f of x. And delta x is the same as del of x. And the interval AB is given in the question is here from 0 to pi. Make sense? So I'm gonna like give small notes before like solving a question like that. Here I can say we're going to replace the limit sum, like n goes to infinity from I equal 1 to n by here to n by this symbols, the integral. Also, we're going to replace xi stars by the value x. Also, we should to replace delta x by del of x. This is the important notes. Now we can use this notes to find the integral here, to express the integral. So what's the integral now? What is the integral? I need some participates. What's the integral? Yeah, who can solve this question? What's the integral? This is the same as the integral of what?
Is it pi on the top and 0 on the bottom?
Okay. Now what's the f of x?
F of x is sine xi.
So this is f of xi star. F of xi without star. So f of x is the same as so f of x is the same as f of xi, but without the I. You have to remove the I.
So f of x,
We will what? X to the power 3
f of 3
plus
plus sine x.
x, because we have x here.
Oh
You
yeah,
see,
we have
please? Yeah.
x times sine x.
Sine of x, correct. Sine of x times what?
Delta x.
Delta
Or
x
just
is
x. Or
become
dx.
del of x, del of x, del of x. Again, this things is this. This things as the symbols here. And the function here is this. Okay, this is just you should to know how to express the limit sum by integral. Okay. Now we're going to evaluate the definite integrals. Before we go over like evaluate definite integrals by using the limit sum. Any questions? Anyone has a questions? No questions. Okay. So I'm gonna like go over how we can evaluate. Now we're going to learn how to evaluate the definite integral. Evaluate the definite integrals. Okay, so we're going to use the limit sum as I said before, by using the limit to evaluate. So we're going to use by using the limit to evaluate the definite integrals. So we have some properties, very important property of sum. We're going to use this properties for sum for evaluating the definite integral. So again, definite integral, so we started how technique to evaluate the definite integral. Next section, next sections in 5.4, we're gonna learn how we can find the definite integral without using the sum limits. I think it's next class. So here, number one, you should know the sum for one all the time from I equal 1 to n is the same as n. What does that mean? This means like 1 plus 1 plus 1 plus 1 plus 1 plus 1 n times. N times. Okay. So the total for plusing when we add ones is the same as n. Number two, you should know the sum for I starting from 1 to n is the same as the formula n times n plus 1 over 2. Again, what does that mean? This is mean like 1 plus 2 plus 3 plus 4 plus dot 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 plus n. So the total sum is n times n plus 1 over 2. Number 3, the sum of I squared. I starting from 1 to n is the same as n plus 1 to n plus 1 over 6. And number 4, the sum of I to the power 3, I start from 1 to n is the same as n times n plus 1 over 2. Is similar to this things here. It's similar to these things, but we're gonna square it. Square. So this is the same as 1 square plus 2 square plus 3 square plus dot 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 plus n square. And this is the same as 1 to the power 3 plus 2 to the power 3 plus 3 to the power 3 plus n to the power 3. Okay, number 4, I mean number 5, the sum of constant times a to the n to the I sequence, I equal 1 to the n is the same as c, I can take it outside, the sum of ai from I equal 1 to n. Number 6, the sum of ai plus bi, I starting from 1 to n is the same as the sum for the first one plus the sum of the second one. I is equal 1 to n, I equal 1 to n. And also number 7, the difference ai minus bi is the same as the sum of ai minus the sum of bi. I starting from 1 to n, I equal 1 to n, I equal 1 to n. Okay, we're gonna use this property for sum to evaluate the definite integral. I'm gonna give you an example how we can use these things. So example, the question is evaluate the integral from 0 to 3 for the function x to the power 3 minus 6x del of x. Okay, so what do you know about the integral? Is the same as what? Limit sum, correct? The integral is the same as limit sum. So I'm gonna like write here now, write down here, this is equal the limit of the sum of the same things by using the theorem before, f of xi delta x. Starting from here and goes to infinity, I starting from 1 to n. This is the same as, again, the integral from a to b for the function f of x del of x. The limit of the sum is the same as the integral. So in this example, we're gonna find delta x. We're gonna want to find xi. We need to find delta x. We need to find xi. Block it inside this limit to find the integral of these things from 0 to 3 for this function. Okay, I'm gonna start. What is delta x? By the way, the interval here, so I'm gonna like, before I starting solving the question, I'm gonna like write important notes. So the interval start from which point? What's the interval? Is the same as the limit of the integral. What's the interval? Exactly, Friday, from 0 to 3. So 0, 3. This is the interval. My second question, what is f of x? What's the function of x?
X cube minus 6x.
Exactly, is x3 to the power 3 minus 6x. Okay, now we're going to use the limit sum. We're going to use the limit sum to find the integral. Okay, now first of all, we have to find delta x. What is delta x? Is the same as b minus a over n. What is b? Yes,
It's 3 over n.
3. B is a 3, right? What is b? Is this b? What is a? This is a over n. 3 over n. 3 minus 0 over n is the same as 3 over n. So this is delta x. Okay, so I'm gonna like graph a line again, because when you find delta x, graph a line right away, 0, 3. Here's first point x1. This is the second point x2, x3, dot dot dot. Here's the point xi. Okay. So x1 is the same as what? What is the value of x1? How we can find the value of x1? Is the same a plus delta x. What is a? 0 plus delta x. What is delta x? 3 over n. So what's the answer? 3 over n. So the first point is 3 over n. Second point, x2 is the same as a plus 2 delta x. Is the same as 0 plus 2 times 3 over n. Is the same as what? 6 over n. Okay, if I keep like going, finding x3, x4, x5, we're going to find xi. What is xi? Is the same as a plus I delta x. What is a? 0 plus I times delta x is 3 over n. This is equal 3i over n. So I find the value of xi. It's 3 over n times I. So again, back to the question. So they ask me for delta x. I find delta x. It's here. Now I find the value of xi. It's here. Now we have to plug to find the limit. Now it's easy to find. Now find the limit of the sum. Okay. So limit of the sum of f of xi delta x I starting from 1 to the n and goes to infinity. This is the same as the limit of the sum of f of xi 3 over n I. Okay, delta x is the same as 3 over n. I started from 1 to n and goes to infinity. Again, because the function depending on I, the function is here the sum depending on I. So this is constant. I can take it outside the sum. Make sense? I can take it outside the sum. So this is the same as the limit of 3 over n, the sum of f of 3 over n I starting from 1 to n. And again, we're going to plug these values inside the function. We're going to plug this value inside the function here. We're going to plug 3in inside this function. Now, after we plug the value, what do you get? I'm going to like do it here. F of 3i over n is the same as 3i over n to the power 3 minus 6 over times 3i over n. Okay, simplify it more. What do you get? What is the 3 to the power? Like here, we're going to distribute inside the parentheses to the power 3. 3 to the power 3 is what? What is the 3 to the power 3?
27.
7. Okay. Over n to the power 3 times I to the power 3 minus 6 times 3. What is it? 18 I over n. Now we're going to plug these things inside the sum. These things, I'm going to plug it inside the sum. here. I'm going to plug these things here inside the sum. Instead of f3n 3i over n, I'm gonna put these things, this value. Okay, this is equal limit when n goes to infinity, n goes to infinity, 3 over n sum 27 over n to the power 3 I to the power 3 minus 18 over n I from I equal 1 to n. Again, because the sum depending on I, so all these things is a constant. I can take it. First of all, I'm going to distribute the sum inside the parentheses. First of all. Second things, because the I here, like this sum depending on I, this constant will be like outside the sum after like distributing. Makes sense? So this is again, this is the limit of 3 over n. Again, this is 27 over n to the power 3 sum I to the power 3 I is equal 1 to the n minus 18 over n sum of I starting from 1 to n. Okay, now we're going to use the formulas for the sum. What is that equal? It's the same as these things. And what is the sum of I? It's the same as like these things. This is the sum of I. This is the sum of I to the power 3. This is the sum of I. Because here, like it shows minus, I'm gonna like put it like this. No, like that. Okay. Okay, I'm gonna just now substitute the sum of I to the power 3 and the sum of I inside the sum notation. So I'm gonna get the limit here n goes to infinity, by the way. Limit n goes to infinity, 3 over n, here 27 over n to the power 3. Here's the sum of n plus, I mean like here it will be like n times n plus 1 over 2 square minus 18 over n. The sum of I is the same as n plus n times n plus 1 over 2. Okay, I'm gonna simplify everything now. I have limit. I have like something like something I saw it before. I have saw it before. Okay, so now I'm gonna distribute the 3 over n inside the parentheses. Here I'm gonna like expand these things, distribute, simplify everything. Okay, so here's the same as the limit. 3 times 27 is what? What is it? 3 times 27 is 81. 81, correct. So it'll be like 81 over n to the power 4 times these things here inside. It will be like something, I mean like a 2 square, it will be like 4, I think. And inside here in the top, I'm gonna like do it so quickly, is n square times n square plus 2n plus 1 minus 18 over n. Oh, by the way, I'm gonna like multiply again these things with the 18. What do you get? What is 3 times 18? 54 over what? N square. Here I'm gonna get n square, and after expanding, n square plus n over 2. When n goes to infinity. So far so good? So far so good? Any questions so far? Okay, now,
I have a
yeah,
question.
go ahead.
So what
go
we
ahead.
exactly finding? Are we finding the
Limit. We're finding the limit. When
Why
n
are we
goes to
finding the
infinity.
limit?
Okay, Why are we finding the limit? Because again, the integral is the same as the limit of the sum. Make sense? The integral is the same as the limit of the sum. We find the sum. We actually find the sum. What's the sum? Is delta x. We find delta x. This is delta x. Here's f of xi. Here's the value of xi. Plug the values. Like this is the value of xi. We plug it. We find it. Then
So
after,
so
go
we're
ahead.
finding the definite integral, right?
Yes, we can find the definite integral. Like here, I'm doing step by step. So the limit of the sum is the same as the integral. The limit of the sum is the same as the integral. So again, I do it step by step. I find delta x. Here's delta x. I find the value of f of xi. Here's the f of xi. I take the sum. Here is the sum. Then I use the properties in the above for the sum of I to the power 3, because I want to remove the notation of sum. So I remove it. How I remove it? By using the property. Now it's easy to find the limit. Now we need to find the limit. Our goal is to find the limit. Okay? But which limit? When n goes to infinity. Now we're going to distribute the limit inside the parentheses. We're going to distribute the limit inside the parentheses to find the value of the integral. So this is the same as the limit. Oh, by the way, the limit is depending on n. It's depending on the value in the variable n. This is mean all the constant, we're going to put it outside. Make sense? So I'm going to first of all distribute the limit. So the limit of 81, here n to the power, I'm going to distribute again n to the power 4 plus 2n to the power 3 plus n square over 4 n to the power 4 when n goes to infinity, minus the limit of 54 times n square plus n over 2n square when n goes to infinity. Because here is the limit asking about when it goes to infinity, as we learned before, the limit when it goes to infinity is the same as, first all you have to check what's the highest power in the numerator and the highest power in the denominator. So what is the value of this limit, as we learned before, is the same as, because the highest power in the numerator is 4 and the highest power in the denominator is 4, so it would be like the coefficients of the highest power. So what is the limit for the first one? What is the limit for the first one? For this side? I'm gonna distribute the limit. This would be like 81 n to the power 4 plus 81 times 2 is the same as 162 n to the power 3 plus 81 n to the power 2 over 4 n to the power 4 minus the limit. Okay, n goes to infinity. 54 n to the power square plus 54 to the power n over 2n square. Okay, as we learned before, we said if they have like the numerator and denominator, they have the same highest power, the limit when n goes to infinity is the same as the coefficient. Coefficient of what? For the n to the highest power is 81 over the highest power, over the coefficient of times the n of the highest power is over 4. So the first intake for the first limit, it would be like what? Like, yes, exactly, 81 over 4 minus. And the limit for the second part is what? The same things, 54 over 2. And the answer for these things will be like minus, multiply both sides by 2 here for the second derivative, for the second fraction, would be like 81 minus, minus 104
Answer
over
should be
4.
negative 27 over 4.
Exactly, negative 27 over 4, and this is the same as if like you want to use it in decimal, to minus 6.25. So this is the value of the integral. This is a long way to find the value of the integral. We're going in the next section, not using the limit sum. Limit sum takes a long time to find the value of the integral. But you should like to know how to evaluate by using the limit sum, by using the theorem of for the integral. Okay.
So there's an
And
easy way to do this.
Yeah, next sections we're gonna learn how to do it like so quickly. But if the question in the exam they ask you the limit sum, you have to know how is use the limit sum. You have to use the limit sum of f of xi times delta x. You have to find the delta x, you have to find the f of xi, you have to find the sum of the f of xi, you have to use the limit to find the value of the sum of use the limit to find the value of the integral. Make sense? Again, why it's negative here? Why it's negative? Because the area, what is the area? The area below the x-axis is greater than the area above the x-axis, okay? The area below the x-axis is greater than the area above the x-axis. Here's the graph of this function. I'm gonna take a screenshot, add it to the notes. So A2 here is greater than A1. So add photo.
Professor,
Yeah, go ahead.
how do you get 104?
How get 1 over 4?
No,
Which one?
over here and towards the end, where it's 81 and subtract 104. How you
Here,
got
this
104?
you take about this one.
Yeah, but the one next to
Okay.
it.
Okay. So we have two fractions, right? The first fraction, the denominator is 4, and the second denominator is 2.
Shouldn't it be 108? Because it's 2 times 54.
Yes, I'm so sorry for this. Correct. Like 52 times 2, correct. So multiply by 2 for both sides, correct. Yeah, you're right. 108. 108 minus 108 minus 81, I will get 27. Correct. Gonna fix it. Yeah. We multiply both sides by 2 to make the denominator equal. So I get like 81 minus 54 times 2 is 108. Okay. So the answer here is negative again. Why? Because the total area below the x-axis is greater than the total area above the x-axis. That's why the integral here is minus. Okay. Any question? Now we're going over like, but instead of using the left endpoint or right endpoint, we're gonna use the midpoint rules. The midpoint rule. I'm gonna give you like the formula very quick for the midpoint rule. So here the midpoint rule. Same like before, but here instead of using the left endpoint or right endpoint, we're gonna use the what? The midpoint. The midpoint is the point is between in the subinterval. The integral for a to b of x. The f of x is the same as the sum. Here is not the same. Here now we're going to use the limit because we're going to use the approximate. The sum for I equal 1 to n for the function f of xi, the bar. This bar means the midpoint delta x. Again, this is the same as delta x times f of x1 bar plus f of x2 bar plus the dot plus f of x and bar. Okay, now what's delta x? Like before, delta x is the same as b minus a over n. And what is xi bar is the same as the midpoint is the same as xi minus 1 xi minus 1 plus xi. Okay. Here's without, I'm gonna clean it. Okay. So the same like before exactly, but instead of using the endpoint, we're going to use the midpoints. Okay, I'm gonna give you example. So quick example. The example said use the midpoint rule with n equal 5 to find the integral for 1 over x, that of x from 1 to 2. Okay, my question is, what is the interval? What's the interval?
1 to 2.
1 to 2. What's the function of x? What's the function? 1 over x, correct. And what is n? It's 5. Now we're going to use this formula to find the integral of from 1 to 2 by using the midpoint. Same step like before, nothing different. First of all, we're gonna find delta x. What is delta x? Is b minus a over n. What is b? 2 minus 1 over 5 is the same as 1 over 5 is the same as 2 over 10 is the same as 0.2. I'm gonna graph a line like this. This line starting from 1 up to 2. And we have like 5 subintervals. So we're gonna divide, I'm gonna divide these things up to 5 subintervals. Okay. So here is the first 1, 2, 3, 4. I'm gonna clean these things here. So I have 4 subintervals. I mean, I have 5 subintervals. This is number 1, number 2, number 3, number 4, number 5. Now we need to find the values for x1, x2, x3. This is x1, x2, x3, x4. Okay, what is x1? What is the value of x1? Is the same a plus delta x. What is a? What is a here in this example? What's the first point?
Is it 2 over 5?
Is, I mean, like, my question is, what is a? What's the value of a? Is the
It's
starting
1.
point of the interval? Is 1, correct. So it'll be like 1 plus delta x. What is delta x? 0.2. This is my delta x. So it'd be like 1.2. This value is 1.2. Okay, the same things for the other points. But instead of using the formula a plus, instead of using the formula a plus 2 delta x, I'm gonna just keep adding delta x for every time. So it'll be like adding delta x for each to this point, it will be what? Like 1.2 plus 0.2 is what? 1.4. Add another 0.2 for this point, we'll get what? 1.6. And here 1.8. And here is 2, and the beginning point is 1. Make sense? Okay, now we need to find the midpoint. Midpoint is a point in the middle of subinterval. This is my midpoint. And here's my second midpoint. and here is the third one, here is the fourth one, and here is the fifth one. So how can I find this midpoints? How can I find this point midpoints? I have to use the formula. The formula said add 1 plus 1.2 divided by 2. Make sense? So the first midpoint, the first midpoint is the same as 1 plus 1.2 over 2. And this is equal what? 2.2 over 2. And this is equal 1.1. Same things for the second point, the third point, the fourth point. So I'm like, you can like try it as exercise to find all the midpoints, but I'm gonna give it to you as already. So you're going to use the same method here, adding the end points divided by 2. For the second midpoint, you're gonna add 1.2 to the 1.4 divided by 2. Same things for the third midpoint and fourth midpoint and fifth midpoint. So here I'm gonna like write down the all midpoints are 1.1, comma, 1.3, comma, 1.5, comma, 1.7, comma, 1.9. Or if you can like finding the first endpoint, midpoint, this is the first midpoint, this point, just you have to keep the same delta x each time. Adding delta x, you're gonna get the second midpoint. Add delta x, you're gonna get the third midpoint. Delta x, you're gonna find the third midpoint, and so on. So by adding delta x for each time, you're gonna find all midpoints. Okay, so second midpoint is the same as 1.1 plus is the same as, yeah, I'm gonna put it here because no space, 1.1 plus delta x is the same as 1.1 plus 0.2, and this is the same as 1.3. Okay, and so on, the third, fourth, fifth. Could you solve for midpoint if you were not given a value for n? I think you can find the midpoint, but you should to have the value of n to find the midpoint. You have to get the value of n to find the midpoint, because if it's not giving the value of n, it would be like in general. You're gonna find the value of integral in general. Okay, so here is the midpoint. I'm gonna use the formula now. Going back to the formula, here is the formula. This is the formula. The integral is the same as delta x times the f of the first midpoint plus the f of second midpoint up to the xn midpoint. So the integral, just the red color, the integral. What's the question is? Talk about the integral for 1 point from 1 to 2 for the function 1 over x, delta x, del of x equal is delta x times f of 1.1 plus f of 1.3 plus f of 1.5 plus f of 1.7 plus f of 1.9. By the way, what is the function f? What's the value for the function? Is this things. Here's the function. Here's the interval. Here's the how many subinterval we need, 5. So we're going to plug these values inside this function here. Okay, plug the function. What do you get? Delta x, by the way, is 0.2. 0.2. F of 1.1 is what? Is 1 over 1.1 plus 1 over 1.3 plus 1 over 1.5 plus 1 over 1.7 plus 1 over 1.9. So the answer by using the calculator, you're gonna get 0.691. And this is the total answer of this limit. Any question? Any question for this exam? any question for this example. So we can wait, how you got 2 over 10? Okay, how again 2 over 10? So delta x is the same as 2 minus 1 over 5, correct? Is 1 over 5. Multiply by both sides by 2. What do you get? 2 over 10. 2 over 10 in decimal is 0.2. This is the value of delta x. You see delta x here? 0.2. I find it from here. Make sense? Yes. Is 0.1, it's the approximate area, correct, Freddy? Is 0.691 is the area. I can say that it's the net area. I cannot say the area, net area, because if it's minus, like I explained before, like all the time said the net area means the area above the x-axis minus the area below the x-axis. It's approximate net area, Freddy. It's approximate. It's not exactly, it's approximate. Okay, any question?
Oh yeah.
Any question? Yeah, go ahead.
Last time you gave us the homework to do, right? But you didn't tell us
Yes.
like which point we're supposed to use.
Which point I supposed to use? What is the question?
Oh, it was the same question as this. You didn't tell us like, are we supposed to use right endpoint, left or middle?
Okay. Which point? Midpoint or right or left? You can choose whatever you like. If I did not if I did not say in the example what's the sample point you can use the right endpoint, left endpoint, or the midpoint. Doesn't matter.
Okay.
Okay. Now, after we talk about the midpoint, we talk about the right endpoint, left endpoint, and all this stuff. We're going now to go over like the property of definite integral. Now we can like step in to the definite of integral. Now, after like we understand the general idea about the definite integral, now we can go over like to find the definite integral by using the property. So here's properties. Of the definite integral. Okay. First one, you should know the integral for the function f of x, del of x, starting from a to b, is the same as the integral if we want to like flip the endpoints, start from b to a for f of x, del of x, but you have to multiply by what? By negative. This is the first property. Second one said the integral for the same point from a to a for the function f of x, del of x is the same all the time is 0 from the same point to the end point. Number 3, they said, if I have a constant c multiplied by d of x from a to b, the integral for something like that is c times b minus a. The integral for something like that is c times b minus a. Number 4, the integral for the function f of x plus g of x, del of x from a to b is the same as the integral for the first function f of x plus the integral for the second one, g of x, del of x from a to b. Same things for the minus 5, the integral for f of x minus g of x, del of x from a to b is the same as the integral for the first function, del of x, minus the integral for the second function, g of x, del of x from a to b, Number 6, the integral for c times f of x here, del of x. I can take the c outside, the constant, I can take it outside c times the integral for the function f of x, del of x from a to b. This very important properties. Integral, we're gonna use it to evaluate the values. Also, number 7, you should to know the combined integral of the same function. Combined integral of the same function over interval is the same as the integral from a to c for the function f of x, del of x, plus the integral from c to b for the function f of x, del of x is the same as the integral from a to b for the function f of x, del of x. A to c, c to b is the same as a to b. This property is very important. We're gonna use it during the next example. Any question before I move to the next example? C is just a point when within the interval. No, C is a point. It's inside the interval or outside, doesn't matter. It's a real number. C here belong to the real number. Any value, any number is not supposed to be like belong to the interval. No, outside the interval. Any values belong to the real number. Any number. Make sense? Again here, C belong to the real numbers. Any real number. The question from Freddy, he said, C is just a point belong to the interval from A to B? No, C is any number, belong to the real numbers. Okay, I'll give you example. Use the properties of integral to evaluate the integral from 0 to 1 for the function 4 plus 3x squared del of x. Okay, by the way, if you want to like break down this function, this is like as what? F, and this is as the second function g. Okay, how we can find the integral for something like that? By using the property from 1 to 7. Which first property I have to use?
4.
Number 4, correct. Look to number 4. They said if I have two functions, I can like split it out to the first function and the second function. So I can break it down the integral for the first one and the second one. Okay, so this is the same as the integral for the first one, 4 del of x, plus the integral for 3x squared del of x. From where to where? From 0 to 1, from 0 to 1. Okay, now here I have constant. For the first one, this is, I have a constant, 4 del of x. How can like integrate, how can integrate something like that? Which property I have to use? If it's constant del of x, which property? You see this property? So this is similar to this one. So what's the value? Again, this is similar to this one. For the second property, I have 3 times function. I have a 3 times function. This is function f of x. What I should to do for the second property? Which one I have to use? Which one I have to use for the second integral? Which property I have to use for the second integral? And which property I have to use for the first integral? For the first integral, like I said before, I have to use these things. It's c times b minus a. But for the second one, what do I have to use? I have constant multiplied by function. Constant multiply by a function. Okay, what's the value of the integral for the first one? What's the value here? 4 times what? 1 minus 0. Correct, it's 4. Plus, the second integral will be like 3 integral x square that of x from 0 to 1. Okay, this value here is what? It's 4. Correct, it's 4. And here is the same as 3, the integral from 0 to 1, x to the power 3 that of x. Okay, these things here, we saw it in the previous section. By the way, this is square, I'm sorry, this is square. We saw it in the previous section, and I solved example for that. The integral from 0 to 1, x squared that of x is the same as the sum limit, if you remember. Is the same as the sum limit. Okay? The same as the sum limit. And the value from the previous section, we find it as what? What is the value of this one from the previous section? Is 1 over 3. 1 over 3. So you don't have to know what's the integral for something like that right now. But these things, we do example last time, and we find the value is 1 over 3. So it's given. It's given right now. So it'll be like 4 plus 3 times 1 over 3. And what is the answer? It's 4 plus what? 3 over 3. And this is the same as what? 4 plus 1. And this is the same as 5. So the value of this integral is 5. Here's Shinomi said this is the same as x to the power 3 over 3. X to the power 3 over 3. This is correct, but we did not learn the steps for these things so far. Or you can ask yourself, what's the antiderivative of x squared? The antiderivative, as we learned from the last chapter, the last section of the chapter 4, is the same as x to the power 3 over 3. Then we have to plug the values. But we don't have to know it right now. We're gonna like over these things in next sections. But you should know the value of these things is 1 over 3 from the area from 5.1.
Wait, how did
Any
you get
question?
1 over 3?
What you said?
How did you get 1 over 3?
This 1 over 3, I find it from the area from the previous section. In the 5.1, when I did the example to find the area of x squared, if you remember, like the function like this, I graph something like that. I said find the area for the function, the parabola function, like the parabola function like this. I did like graph like this, and I graph the function, the parabola from 0 up to 1, and I ask we like split out these things as rectangles, and we find the area of this rectangles, if you remember. The area of this rectangles. The area of this rectangles. The total area of this rectangles is 1 over 3. Okay?
Alright, so we could just find the antiderivative of this and then plug the numbers and then subtract a to b.
Yes.
Okay.
Now, another example. If it is known that the integral for the function f of x and that of x from 0 to 7 to 10 is 17, and also the integral from 0 to 8 for the function f of x, that of x equal to 12, find the value of the integral from 8 to 10 for the function f of x del of x. So we're going to use which property for the example? This property number 7. I'm gonna like use this property to find the solution for this example. Okay, I have the same function from 0 to 10 for f of x, and from 0 to 8 for the same function. They ask me find from 8 to 10, from 8 to 10 for this function, for the same function. Again, I have from 0 to 10, I have from 0 to 8. They asked from 8 to 10.
Just minus.
Just minus, correct. Or if you want to like write it down, like make a line like this. Here's a line, and the line is starting from 0. I have the point 0, I have the point 8, and I have the point 10. Like this. So from 0 to 10 is the integral from 0 to 10 for the function f of x is equal 17. And from 0 to 8, from 0 to 8 is the integral from 0 to 8 for f of x del of x is equal 12. They ask for this interval. For this things. They ask about this things, the integral from 8 to 10 for f of x del of x.
So
I
you
can write
divide.
down, I can like you said define, I can like write from the integral from 0 to 8 for the function f of x del of x plus the integral from 8 to 10 for the function f of x del of x is the same as the integral from where to where by using the property. They
0 to
said
10.
we have exactly from 0 to 10, from 0 to 10 for the function f of x del of x. Okay, now we're going to substitute. I have the value here. What is the value of these things? It's given
12.
12. And we need, they ask about these values. And I have the value of this. What is the value of this? 17. The value of these things, the integral, is 17, correct? Just you need to find the value of this, x. So I can write down here, is it 12 plus x, like unknown value, equal 17. Now we have to find, like, to solve the equation. It's not that much hard, like a simple equation. How we can find it? So x equal 17 minus 12. And this is equal, what's the value? 5.
5.
So the integral here is equal what? 5. This is equal 5. So the integral for this things is equal 5. Make sense? Any questions so far? Okay, now the last things in this section, I'm gonna go over these things very quickly. It's called the comparison property of the integral. Comparison. Before we finish, comparison properties of integral. Okay, number one, you should know if the function, if f of x is greater than or equal 0 for the value x between a and b, then you should know also the integral for the function from a to b for the f of x all the time that of x is greater than 0, is positive or 0. Number two, if f of x is greater than another function g of x for the values x between a and b, then you should know the integral for the function f of x del of x is smaller than or equal the integral for g of x del of x from a to b. Make sense? The last one, if the function f of x is between two values, like they have a minimum value and maximum value, and this is like for the interval x between a and b, then if I want to use the integral, if I want to like integrate integral, what are you gonna get? Then m times b minus a smaller than or equal the integral for the function f of x del of x from a to b smaller than or equal m times b minus a. Why I multiply by b minus a? Because you have to know, like the note before from the property, the integral for constant m del of x from a to b. This is m, by the way. M is a constant. M here is a constant. This is equal what? By using the property, m times what? B minus a. That's why here in the both side, I put a multiply by b minus a. Okay? So I'm gonna give you like a quick example for like for the third property. The examples look like this. Example. The question asks, use the property above to estimate the integral from 0 to 1 for the function e to the minus x squared del of x. By the way, what is the interval here in this question? What's the interval
0 to
a
1.
comma b? Exactly. It's 0 to 1. And what is the function? What is f of x? What's the function here in this example?
E to the negative x square.
Is e to the minus x squared, correct? Okay. By the way, this function is like this function is decreasing function. This function is decreasing function. Why? Because the power of the exponent here is negative. So this is mean like the function is decreasing. If I want to like show you exactly how is the graph of this function, the function look like this. Look, it's decreasing. The function is decreasing. Okay. By the way, how we can use the property? Which property? I'm gonna use the third property, by the way. How we can use the third property to find the estimate of these things? My question is, what is the minimum value for this function on the interval from 0 to 1?
Is 1.
Is 1, correct? Because the function here is the maximum point is what you said? I mean, like
1.
at which x or at which value from 0 to 1 such that the function has a minimum value?
0, or it would be negative
0.
infinity.
At 0, they have maximum value. At 1, it has what?
Minimum.
Minimum value. So I can say the minimum value, the small one, the minimum value here is f of 1. F of 1 is the minimum. I mean, like f of 1 is the minimum value. Yes, correct. F of 1, here is the 1 in the graph. They have a minimum value. This is the minimum value. This is the minimum value. And at 0, they have a maximum value. So the maximum value is f of what? 0. Okay, what is f of 1 after you plug this value inside the function? What is f of 1? Plug it inside this function. What do you get? e to the minus 1 is the same as what?
1 over
Same
e.
as 1 over e, correct. So this is my minimum value. So the maximum value is the same as f of 0. Plug the 0 inside the function, e to the 0. What is e to the 0?
1.
Is 1. So this is my maximum value. Okay, actually, e to the minus x squared is between the minimum value 1 over e and between 1. Take the integral for both sides from 0 to 1, from 0 to 1, and from 0 to 1. Now, what's the integral for these things here? As we learned before, this is constant, by the way, del of x here. Hold on, I have to write del of x too. Del of x, del of x, del of x. What is the minimum value here? What's the integral for these things? By the way, this is a constant. Why? Because there is no x, no variable x. Why it's constant? Because there is no variable x. I do integrating respect to the x. That's why this is a constant. This is a number. What is the integral for these things?
1 over 2 e
1 over
squared.
e times what? 1 minus 0. Correct? By using the property. Less than or equal the integral from 0 to 1 e to the minus x squared del of x smaller than or equal what? What is the another integral? What's the another integral? Do you know me? What's the another integral? Is the same as 1 times what? One times what? 1 minus 0. B minus a. B minus a. B minus a. Okay, so the integral 0, 1 to the e to the minus x squared del of x is between two values. What's the first values? E to the minus 1 and 1. By using the property of integrals. Any question? Any questions so far? Do you have any question? Okay, this section is done. This section is done. Now I'm gonna talk about the next section. Next section is talk about 5.3, the fundamental theorem of calculus. I know we have 2 minutes before we end this class, but I'm gonna write down the title for 5.2. 5.3 is the fundamental theorem. Fundamental theorem of calculus. They have two parts. They have two parts in this section. Part 1, let's talk about the the integral g of x equal the integral from a to x f of t del of t. I'm gonna explain it next time because we don't have a time. It's the same as if I have a graph like this and I have a function like that. So they said the integral from a to x is the same as g of x. So this is my x, this is my a, this is my b, and this is g of x is the same as area, as the book said. Okay, I'm gonna explain this more for next time, but you should to know this is the definition for the part 1. G of x equal the integral from a to the x for f of t del of t. And there is another part. We're gonna over the second part also next time. I'm gonna give you more example, for 5.3, the fundamental theorem of calculus. Then we're going for 5.4 to explain exactly how we can use the definite integral and indefinite integrals. So I'm gonna stop this lecture for today. And before I stop, do you have any question? There is any question in this section for this lecture? Okay, no questions. So I'm gonna stop recording this class.